All right, go right ahead. So Shamark, this is the active camera, right?
Jesus is coming again, he's coming in power and glory to reign. Coming with all the heavenly hosts, what a glorious time that will be. See the signs fulfilled one by one, study his word, be watchful and wait. He's coming soon like a thief in the night. Jesus is coming again, he's coming in power and glory to reign. Coming with all the heavenly hosts, what a glorious time that will be. Coming together his faithful children, won't you be one of the faithful few? Cast yourself at the Savior's feet, he's calling you now to come.
Good afternoon. Welcome once again to another series of Bible class studies here from the Spanish Town St. Adventist Church in Spanish Town, St. Catherine, Jamaica in the West Indies. I am happy that you're joining us from wherever you are in the world, not just here in Jamaica or here in Spanish Town or the close-up
Part of the diaspora, but internationally. If today is the first you are joining us, then you have missed a lot. But not to worry, because you can simply go back and catch up on all you have missed. We have covered so much on this subject of the creation. And in fact, this will be continuing for a while. And we are only on that part of it that we refer to as the purpose of creation. And in this section of the purpose of creation, we are looking at four major headings. One, the nature of God. We have covered that already. And we have been on this second one for the last 3 weeks. No. Creation of the universe, not just the earth. And in this section, we have set out to show you that God's creation, as described in the Bible, is so much more than just the earth. It's so much more than just the sun. It's so much more than just the moon and the stars. And we have been exploring his creation in space. All those other bodies in space that constitute his creation. It is so much that it's a challenge for me to condense the information to share with you. But it is such an exciting one.
Oh, yes,
when you
we have covered billions of miles.
Several light years of space. Right. And I can tell you, for me, it's an humbling experience. Oh, yes, because indeed. I recognize, when I was thinking about it this week, and I said, God is such a big property owner. You know, it makes me think that, man, we are going on with foolishness in this world. When we're running down properties, one country invading the other because of property, you have people fighting over lands. And when I think of what is out there, in fact, friends, from all of what we have considered so far, we have recognized that if you should take a look at the entire universe, our galaxy, okay, we're having a little issue with our sound, but our galaxy, not just Earth, but our galaxy would be invisible to the naked eye. So large it is that you would not be able to see our galaxy. And our galaxies has billions of stars, like the earth, like the sun, but it is invisible. And I'm saying that if the universe is so large that the galaxy in which the earth is situated is invisible, how comes God is so interested in that little speck that you can't see with your naked eye? In other words, we would be like an electron, for those of us who understand electricity. It's the smallest particle of electric current. It's not visible in no way to the naked eye. In fact, I think it's only recently that the most powerful magnification was developed where they can see an electron. But just to show you that the earth is invisible in the larger sphere of things. But it is where God's interests seem to be most centered. So join with us as we continue on this journey of looking at the creation of the universe. And that is not just the earth. Elder Barrett, pray for us.
Heavenly Father, we are truly humbled to know that you care about your creation. We often think so much of ourselves, but when we compare to the work of thy hands, we see how seemingly insignificant we are. Help us to place our trust in you and to recognize that in you all things that we desire can be. So help us to seek after you, that we may find you, a God who is supremely ours. Guide us, we pray, as we explore your handiwork. In Jesus' name, amen.
Amen. The creation of the universe, not just the earth, a quick little recapitulation of our covering ideas. Now, did God create the earth only? The answer is no. In Genesis 1, the Bible speaks of the creation of other bodies apart from the earth itself. Genesis chapter 1, verse 1 is our anchor verse for the creation description. And it says, in the beginning, God created the heaven and the earth. And those two we are studying really. And in Genesis 15, verse 15, and he brought him forth abroad and said, look now toward heaven. This is God speaking to Abraham. And tell the stars, if thou be able to number them. And he said unto him, so shall thy seed be. And in Isaiah 42, verse 5, thus says God the Lord, he that created the heavens and stretched them out, Elder Barry. He that spread forth the earth, and that which cometh out of it. He that giveth breath unto the people upon it, and spirit to them that walk therein. Giving us a hint there that he has so much more out there than the earth. No matter how the earth seems to be so big to us.
But you know, looking at verse 1, as you just mentioned, it's that verse keeps anchoring us.
Yes.
If we look at it from a scientific point of view.
One moment. Can I lower the mic a bit? Because we seem to be
right. So. If we look at it from a scientific point of view, we could begin it like this. In the beginning, God made this seemingly insignificant and the eternal expanse. Because when you look at the heavens, it's too much to comprehend. And when we think of the earth in comparison, we are but a little pinhead, lost in the insignificance of what is out there and what we are really a part of.
And that is, for me, is the biggest lesson I have come to learn, our insignificance. And it tells me that we ought to be humble, because the world is so much more than what we know of it. Now, our home galaxy, the Milky Way, contains several 100 billion stars, many like our own sun. Now remember, you know something about the sun, friends. And picture that the galaxy, I'm not talking about the universe now, but the contains several 100 billion stars like the sun. So the sun has brothers.
The sun is a star.
The sun has 100 billion brothers and sisters.
And we are not the biggest. We are,
No.
we are numbered among the smallest.
And that's just in our galaxy.
In our galaxy.
And the universe has billions of galaxies. Get that? Now, although this may be an almost unfathomable number, this is only just the tip of the iceberg. Astronomers believe that there are more than 100 billion galaxies in the universe. Consider how many stars that would be. Now, that's where we left off last week. And we are going to show you this picture. We're showing you this picture now of our galaxy, the Milky Way. The arrow points to our solar system in one of the outer arms of the Milky Way galaxy. So, on a scale basis, look at this circle, friends. That's the Milky Way galaxy. And that little tiny circle with the arrow pointing to it is where our solar system resides. So that's where our sun with the planets. So when you look at that circle compared to that little circle that represents our solar system, you begin to see the scale of which we are speaking. So,
and it's not the white circle, you know, it's the little dot inside it that we...
That's right. So the circle itself is very big compared to the little dot. So when you magnify that on the universal scale, you realize that it's invisible. You understand? We are invisible, but that's where. So let me just backtrack a little bit to show our friends where God has planted his interest. That little dot in just the Milky Way galaxy is where God has planted is what we consider the cream of this creation, the star of his eyes. That's where we live. Now, why we don't live on one of the bigger planets, Barry, that is something that we're going to look at next week. So join with us now as we look at the solar system, home of the planet Earth. Now, the Milky Way contains several 100 billion stars, many like our own sun. Our solar system is therefore just one of the several 100 billion such solar systems in the Milky Way where we live. Elder, tell us what is in our solar system.
Science says in the building or the creation or the birth of a star from cosmic dust and gas and such, when the star is born, matter begins to shed off from what is gathered around that what would have been a supernova explosion, because that is how many are born, from the matter that remains. And so when that star is born, there's other matter around it that it is pulling, but it doesn't come into that one solid mass. Hence it revolves around and begin to coalesce or adhese, if you understand scientific terms, together. And so they begin to clump. And so you find that the different sizes of clumps begin to form. Now this is our conjecture, science is conjecture. And gradually they keep revolving around because that central mass has a gravity which keeps them locked in a centrifugal path.
Yeah, pulling them together.
And so you find that depending on the distance from the main body, different things will happen, so that one may be in too close and certain reactions will happen. Another will be a little further away and different things will happen there because of the distance from the radiating body. So according to science, we are in a Goldilocks zone, the habitable zone, where oxygen and nitrogen will be allowed for.
Okay.
Now, there's something I wanted to explain. Those of us who are scientists, there is a tower that is used in the petroleum industry for different type of gases or liquid or gas that comes off the petroleum going through it. So you may have methane at one level, kerosene at another level, methane, butane, and so forth at different levels. So the further out you go, the radiation that reaches from the sun will not allow for certain reactions. And so some will develop into gas giants. So they only have a semi-solid body deep within. While ours, the ones formed inner, closer, became rocky planets. And so the planets now develop according to that. So the theory is that something like this happens in the other systems. And so you may find planets, exoplanets as we are now calling them, that may be in the habitable zone, or some may be circulating, orbiting too close to the parent star. And so it's one side is devilishly hot, and the other is frigid cold.
Okay. All right.
And so nothing can really exist in that situation. And so the planets develop like that.
All right, and of
according
course,
to man.
Yes, according to man, because the Bible did say that in the beginning, God created the heaven and the earth, which means that he would have just done what is to be done as far as putting the universe together. However, we will not rubbish the findings of science.
No.
And with the development of science over the years, many of the theories that were there initially with the first scientists and the first astronomers, they believed something. And much of that knowledge was also controlled by the church. Yes, and the church would subvert science, you know, on the basis of not just the church must have the say where knowledge is concerned, but also what one would call scientists were looked on as how we would look on witches and wizards today. Right? People who are very bright, or people who are exploring,
very knowledgeable,
and going outside of the taboo of what scientific knowledge was. They were subverted, they were suppressed, and were seen as a problem. Now, in terms of what Elder Barry just said about the birth of stars, as explained by science, is that the more man is looking into space, they are seeing evidences of what could have been and what will be as far as the universe is concerned. And one of the things that he mentioned was the birth of stars. Now, the Bible says that God made the stars also. So we know that if the stars are being born now, then if that is so, then what I'm seeing, friends, let us say we're going with science for a little bit. If stars are being born, stars exist from creation, but science is seeing where stars are being born, then we could conclude, and I'm going to say we could conclude, that God created the universe in a way that it would replenish itself. Much like how he created the earth to replenish itself.
Yes.
So, one of the ways in which the earth replenishes itself is through us human beings. The original human beings are not alive today, but they reproduce because God created in them the ability to reproduce so that the first human beings, our human beings did not come to an end with the death of the first set of human beings. And there have been generations and generations. So it is with the animals, so it is with the trees. Not only that, when you look at the systems on the earth, they are designed in a way to replenish. So nature is generally designed to replenish. Some people will say that God keeps, that nature is wrapped up in God and it is God who keeps nature going, and if God should withdraw his hands, nature collapse. And in other words, it would be like suggesting that God has embedded himself in nature and now has the burden of keep it going. But that's not how God has designed the earth.
No.
He can withdraw the science that he has put in place. But it does not, the universe does not, he does not have to be there, say, oh boy, I have to hold up this thing, or if I let it
It does
go.
not collapse on his withdrawal.
Right. He has, and not only that, he has done it too, so that we, the inhabitants of the earth, still speaking about the earth, cannot destroy the earth like that. Last week I talked about one of the first laws of the conservation of energy in nature, and that is, and this is a law we use in science, and nobody has proven it wrong. Matter cannot be created nor destroyed, right? The conservation of mass, conservation of energy. Energy cannot be created nor destroyed, but can only be converted from one form to another. So let's say you're generating electricity. You start with oil. You burn the oil, that's a chemical reaction. You get heat. You use that heat and you boil water. That water now has kinetic energy in the steam. That energy in the steam is used to turn a turbine, giving you mechanical energy. That mechanical energy in the turbine is converted to electrical energy in a generator. And that appears as electrical power in our socket. We pull on that and we are running our computers, we're running our microphone, we run our blenders. All of that was originally coming from the oil.
But look at it. Look at it.
Energy and guess what? Just to finish this point, Elder Barry, guess what? Even though we're consuming that energy, nature is designed in a way where energy is just moving around. So in using the energy to run the microphone, I have not destroyed energy. I have merely converted it from one form to another. So nature is always in balance. And later down the road, when we're going to look at the science of creation, and we're looking at all the systems and what that goes into the running of the earth, that will come out some more. Elder, you were saying.
Look at what we are sitting here before. Plastic.
Yes.
Plastic.
Welcome, Mike Cola. Yes.
And
yes,
all
the topic
of this
is still creation. Mike Cola. Oh, okay, right. That was Keroy making that, giving that information. Yes, the subject is still creation, but we're looking at a different aspect each week.
From a different angle.
And from a different angle. So we're on the subject still of creation of the universe, and this week we're looking at the creation of the solar system. Continue, Elder.
Yes, so I was saying, all of these things we are using here, plastics, and they come from the petroleum.
Yes.
And other elements in nature.
Yes.
And we burn the petroleum to get fuel, to run the machine, to create the molds, to make these things that come from the very oil again.
And that oil is coming from the earth.
So it's a cycle.
Yeah.
So the energy, as we say, is not being destroyed, it's only changing
From
shape.
one form to another, right? Now, of course, with the action of man, we are putting nature out of balance. But that's another story. We'll hold on to that for later. All right. So our solar system is said to contain one star, that is the sun, 8 planets, 5 dwarf planets, 200 plus moons, 1,113,527 asteroids and 3,743 comets. Now just look at this little basket list. Those are all the elements of our solar system in which we live.
The basic of a system.
Yes.
Because there are discovered worlds out there that have two suns.
Yes, so in our solar system, this is its makeup. But as Elder is saying, that there are other systems with more than one star constituting the head of that system. All right? So now a quick reminder of what a star is, Elder.
A star or sun is a...
No, let me correct you there. Sun is actually the name given to
our star.
Right, so you're speaking in general
so
terms.
A star then is a luminous ball of gas. Mostly hydrogen and helium. Well, it's the reaction that happens there brings it down to helium. And this is held together by its own gravity. So the heavier elements will fall in, like iron and so forth, will fall into the core. Nuclear fusion reactions in its core support the star against gravity and produce photons and heat, as well as small amounts of heavier elements, the iron and so forth that I just mentioned. And the sun is our closest star. So when these elements fall into that core and react and radiate, it radiates outwards, but there's pressure from outside.
All right.
The hydrogen and gases there.
I want to expand on this a little, Elder Barry, because what is being described is a nuclear reaction. Now,
Yes.
I know many persons would have heard of it, while many of our listeners will also know of it and understand the science behind it. Now, we have been delving in a lot of science for the last couple of weeks, and I do hope you are following us, because not only are we talking about God now and the Bible, but we're looking at the science of how God works. And every child of God is a part of the universe.
Oh, yes.
And when you study how God does his thing, you're amazed, and science is an explanation of how God does his thing. Now, back to the subject of how the sun produces its heat and its light
the star
here.
produces its heat.
The Elder was describing the nuclear fusion is one of the reactions between two different substances in nature. But this reaction is at what we call the nuclear level. Quick little lesson in chemistry. Every substance in nature, the smallest element of it is called an atom. That atom is made up of other particles called electrons on the outside, from which we get our electricity. But it is in that area of the atom, the outer area, that reactions between one element and the other to form other substances. So when we burn fuel, for instance, and we're combining fuel with oxygen, it's really the electrons on the outer portion of those smallest particles constituting this substance that are reacting together to give you your carbon dioxide and your water and all of the byproducts of combustion, right? However, the core of every atom is called the nucleus.
Yes.
Now, the nucleus itself is constituted with other particles, neutrons, photons.
Is it nanoparticles?
Yes, neutrons and protons. Neutrons, and protons. Now, when these react, so when substances react at the nuclear level, it's called nuclear reaction, and it gives off a lot of energy compared to what you'll get when they are just reacting from the external portion of the atom. So what is happening in the sun, and this is what God has put together, friends, and we're only finding it out, right? Is that helium, which is the second lightest known element in nature, And that's another story we talk about. When we look at the science of creation, and we're going to look at all of those 23 atoms that makes up the system, the matter in the earth and in the universe. Helium and hydrogen react together in a nuclear reaction. So the point here about produce photons is that these are the particles that are ejected from the inner part of the atom, its nucleus. And when they collide with another helium atom, that's where you get the reaction from. So what God has put in place is an energy source that is self-propagating, and it is generating its own energy. And the wisdom of it, and man has always been trying to copy it. In fact, this is where man got the nuclear bomb from, by the way. This is the same idea, right? And this is how the nuclear bomb operates, just like how the sun operates. And that is the reason why an atomic bomb, whatever they call it, nuclear bomb or atomic bomb, that is the reason why it is so powerful. Because it is actually using the same principle that the sun used to produce its energy. And God designed it in a way that, guess what? These reactions are replenishing themselves. And I don't think we have been able to capture that yet. So even though helium is breaking down into hydrogen when a neutron, when a photon collides with it, in the sun also, it is replenishing that reaction. So it's like it is reversing that reaction. Now, Elder, I have a theory, right? And this is a theory of mine, friends. I don't know if it is anywhere. I ask myself that if the sun is generating so much heat, and in one study, it is said that the amount of energy that falls on just a small section of the Sahara Desert in Africa, not the entire desert, but a small section, is enough to power the entire earth with electricity. All of the electricity that we can consume, the amount of energy from the sun that is striking just a small area of that desert,
if we could harness it.
If we could harness it, is sufficient to power the entire world. All the lights and power and what have you that we use in the world, we could just use a small section of the Sahara Desert. Now, if all of that energy is striking the earth day in, day out, Elder, how come we're going to burn up and disappear? Long time. I have a theory, friends, and you can think about it. I am of the view that just as though we were describing about God doing everything as a cycle and as a replenishing, the cycles are designed to replenish. I am of the view that the energy that falls on the surface of the earth and in the rest of the solar system eventually cycle back to the sun. How it is done, only God knows, because that's God's business. If not, where would that energy be gone?
Okay, it doesn't cycle back to the sun.
Your theory, no, huh? Let me
But
hear your
based
theory.
on science, we are really going deep science in this, you know. Based on the theory, God has placed around the earth, in fact, there is around the earth, and there is around the solar system. There is a magnetosphere around the earth, and when the plasma from the sun strikes, they show you on this by demographics how it flows around. And so the full impact does not hit us,
Elder,
because we have an atmosphere.
That's the full impact, Elder. I know where you're going. I will talk about the ozone layer and all the ozone
right.
layer. But
it
that's
protects
different.
us.
That's different from what I am saying. The impact, in other words, I am saying that a small portion of the Sahara
if we could
Desert
use
could
that.
power the
So-
entire world, which means that energy is reaching us. And we know that. You walk out in the sun and you see the light and the heat. But what you're saying now is that the full impact from the sun is not reaching us. It's true. But I am saying what reaches us where does it go eventually? Because if we're constantly absorbing heat, and we would have been burnt up long time ago. So that energy must be going somewhere. Not talking about that has not reached us, because if everything was reaching us, we would have been decimated. But anyway, that is a theory of mine.
Yeah, well, some of it bounces back into space.
Yes, man, that's some. I'm talking about that which actually reach. You understand? Where does it go?
Yeah, but it is absorbed by plants and trees and different objects and the earth itself.
All right, Elder, I'm going to take you on. I'm going to take you on one-on-one with it to show you where I'm going. All right, now the types of stars, a star's color relies on its temperature. So when we look out into space, we can have an idea of how hot that star is based on its color, right? The hotter stars emit bluer light. So the blue stars are actually the hot stars, right? And cooler stars emit redder light, which means then that our sun would be considered one of the cooler ones, right? Temperature is also correlated to mass. So the bigger planets, the bigger stars rather, tend to be the hotter one. The bigger, bluer stars tend to be the hotter one. Continue, Elder.
Types of stars. There are red dwarf stars having as little as 0.075 solar masses.
That's the unit of what I use
in terms of size.
Yeah, the mass of
it's
stars.
all compared to our sun.
Yes.
So all right. And a visible surface temperature less than 4,000 Kelvin.
All right. Now, just to quickly let the viewers know what that is. The Kelvin is equivalent in unit to the Celsius. It's just that it has a different starting point. It starts at 273.16 instead of 0. And that's where you get absolute zero from.
Okay.
The theory is that if you're to cool a substance down to absolute zero, so zero as we know it still has a lot of temperature, 0 degrees Fahrenheit, 0 degrees Celsius. But 273 minus is the absolute 0 point. So this is approximately equal to 4,000 degrees Celsius minus 273 from that, which is what, 3,700 and something degrees C. Now that is like near 4,000, divide that by 100, that is nearly 400 times the temperature of water, hot water. So see that, friend? 400 times the temperature of hot water. And you're talking about water hot, boiling water is hot? No. Continue, Elder.
The most massive star known is R136A1. Well, probably, maybe theory, because science also states that Stephen's 218 is the largest star known.
Okay, all right. So this was in 2010.
This is a Wolf Riot star, 265 times the mass of our sun. So our sun is a little baby. Its visible surface temperature hovers at a searing 50,000 Kelvin.
Right, so that's roughly, what? 5,000 the temperature of boiling water. 5,000 times the temperature of boiling water, right?
The temperature of the surface of the sun is estimated at 5,778.
All right, so you see why Kelvin. You mentioned earlier on that there is plasma surrounding the Earth. You see why? Because our surface temperature is just around 30 degrees Celsius on a relatively hot day here in the Caribbean. But at the surface of the sun, it's 5,000, roughly 5,000 times that. And it is because of what you mentioned about the Earth protection, the atmosphere, the ozone layer, all of these that God puts in there to protect the Earth.
Cushions it.
Yes, and to block all of that.
Absorbs
heat.
and reflects.
Yes.
Refracts.
And note too
into
that
space.
temperature on the Earth's surface is constant. It doesn't vary apart from between the seasons or on any given day when there are a little cloud here and there. Now, Wolf Riot stars, named after French astronomers Charles Wolf and George Riot, who discovered them at the Paris Observatory in 1867. Wolf Riot star, often abbreviated as WR stars, are a rare heterogeneous set of stars with unusual spectra showing prominent broad emission lines of ionized helium and highly ionized nitrogen or carbon. The surface temperatures of known Wolf Riot stars range from 20,000 Kelvin to around 210,000 Kelvin, hotter than almost all other kinds of stars. All right, so we have a little idea of what stars are, and I said a little idea. Okay, with all of that, we're still scratching the surface. So we're now going to take a look at our star, the sun. The sun is the star. And it's not just star, but star.
Star of our world.
Yes, star of our solar system in the Milky Way. Don't you love the sun, Sister Sterling? Yes, Sister Sterling is with us.
You just let rain fall for a week straight. And cloudiness, just cloudiness, morning,
Yes.
noon, and
But-
night. And we long for the sun.
But as the next points will show you, that some people love the sun so much that the ancient Greeks personified the sun as a handsome god, Helios. And that is where the term, that is one of the earliest terms used for the sun, right? During their empiric reign, now, the Romans continued to worship sun gods, but they replaced the Greek word for sun with Helios. The Greek word for sun, Helios, with Latin sol.
With the Latin word.
And that's
sol.
where solar comes from. So we're actually borrowing the old Roman terminology for the sun. So friends, when you read in the Bible, the sun and the moon, those are not original words from the language spoken by the Greeks and the Hebrews at that time. But these are terms that are borrowed from paganism, you understand, names that were actually given to them to personify them as gods. But we continue to use them, and they're actually used in their English forms in the Bible, but that's not their original term, and they're pagan, right? Sol, a root word that continues to refer to the sun in the present day, such as in the term solar system. The most powerful sun god in ancient Rome was Sol Invictus, meaning unconquered sun. Now, that one now is the real god. That is the one that they worship as the sun god. And you hear Elder Finsdale always talk about this term when we talk about sun worship, when we talk about the whole point of the replacement of the Sabbath with Sunday, and the implications going back in history where the sun was worshipped in its God form, Sol Invictus, the unconquered sun. What I said no, what the Oxford said no, Elder.
Origins of the sun, of the word sun, rather. According to the Oxford Dictionary, the word sun comes from many sources, including the Latin sol. The Old English sun, S-U-N-N-E, likely derives from the Old Germanic sun, S-U-N-N-E, both attached a feminine gender to the heavenly body. There exist several variants of the word in other languages, such as zon, Z-O-N, or zonne, Z-O-N-N-E in the Dutch. You know that German and the Dutch and German are close languages. Right. Suna, Old High German Gothic or Old Norse. And sonne, S-O-N-N-E, or son, Middle German. But you'll notice that the nearness of this within the region, because the language nearness exists there. Just like you have Latin, Spanish, Portuguese are near languages.
And, they share and German shares some similarities with English, for instance, also too. So coming off that old Anglo-Saxon root.
So history of the relationship between the sun and the earth. Scientists long debated the astronomical relationship between the sun and the earth. During the 4th century BC, Plato and Aristotle exposed a theory called geocentrism, which proposed that the sun revolved around the earth.
So that was the original thinking.
Right.
Yes.
In fact, they thought the earth was flat.
Yes.
The Aristotelian or geocentric model was further elaborated by Claudius Ptolemy in the 2nd century AD. These proto-scientists were so revered that their ideas drowned out the far less influential Aristarchus or Samos of the 3rd century BC, who was probably the first to propose a heliocentric theory, wherein the earth revolved around the sun. Plato, Aristotle, and Ptolemy's geocentric theory prevailed for more than a millennium.
Yes, and that's to show you the influence of what one would say those who are considered or recognized, whether in science or philosophy or religion, they can have a controlling influence on information. Because here it is that Plato, Aristotle proposed that the earth was
The center of all
the center
things.
and the sun actually revolves around the earth. And even though other scientists have the correct explanation, this held for 1,000 years because of the influence of these men. And I want to say that is sometimes why even as a church we have to be careful.
Yes.
How we shoot down ideas and how we try to control ideas outside of the way how we know it, because science and religion sometimes come head on. And the church in the past believed a lot of things concerning science and hold it that this is how it is until it was proven, without a shadow of a doubt that this is not so. The element of science, again, friends, is merely an observation of what God has done. And therefore, we should not use religion to control science, nor should we use science to control
interpret and control
religion.
religion.
Yes, because one, religion is dealing with the relationship between God's creation and God himself. That's the relationship. Science is looking at how God put the universe together from a scientific standpoint, which is merely an observation of the work of God. When you start to blend the two, you can end up with a problem. So the early church was controlling science, and so because of that power that they have, somebody else with another scientific idea, because science does not belong to anyone. And one person's discovery doesn't mean that there's not a better discovery down the road, no matter what.
Or a
is
better
your,
explanation
better
of the theory
explanation.
or
Right.
discovery.
So for us, and that is the reason why some of the better scientists are the ones that are actually Christians, because they know how to deal with both. They know how to balance both worlds. The beauty of the work of God, no one has control over. You can discover it, but you don't have what you call autonomy over it or control over it. And what you know today can change later on when better discoveries come along. Now, earlier on, we were talking about the stars and what the space telescope Hubble had discovered. This telescope is now the eyes of man in space. So earlier, we could only theorize, and we could probably point a telescope as far as it will take us. But now, when you put the telescope up there, and it is able to see things that we were not able to see. There are many things that are now being seen by this telescope that is really beginning to inform us. And that's why I said earlier on, Hubble has discovered what appears to be the birth of stars. You were talking earlier on about how stars form from the interstellar dust, and the theory of how with nuclear fusion they become a gas ball, and then once they become a gas ball, they begin to it's now become like a machine. It's self-propagating, and that the stars have a lifespan. Now, this might seem to go against the creation story.
Yes.
It might appear to go against the creation story. But maybe in the beginning, mankind did not know that the earth was actually replenishing itself. It's quite a possibility then, by science, that the universe is designed to replenish itself. So when stars burn out, stars are formed because God can do it. He can put it in.
Maybe he had put it to be that way.
Yes, he can put it in the system to propagate itself, right? So we cannot say that stars are not born. What we know is that stars were created, but stars could be, burning out and coming back together. Now, the only thing now is that the way how science reasons in terms of time, and creation speaks of a 6,000 years universe, while science is speaking about a 4.6 billion years, because
no, 13.
Yeah,
13 billion.
When you read the information on the sun, for instance, I guess maybe I should say that our solar system, and since that is the part that is important to us, that's where we live, right? Science is saying that the solar system, beginning with the sun, is 4.6 billion years old, right? So I'm going to ask a question. Let's say we are looking at it from science, the scientific views, and then we're bringing in the creation view. There's a body of thinking that the universe is billions of years old, but the organization of the earth is 6,000 years. In other words, matter was not created at the time when the earth was created. The Bible said God called the earth into being. In science, was that the time that he made matter, or was that the time when matter that existed was used to form the earth? And that is one of the, what you call, the debates in the interchange between science and creation. Now, we won't get into that, friends. What we're doing is just enjoying the work of God. If it's 6,000 years, so let it be. If it is 4.6 billion years, so let it be. The one thing we're sure of is that God created it, right? And we don't want to be bogged down in the theories and get caught up in any controversy, right? So we're just speaking about what is out there. Now, for our modern understanding of how the planets in our solar system revolve around the sun now, listen to this. We must thank the Renaissance astronomer, and guess what? Catholic, see how religion comes in? This gentleman is a Catholic cleric, Nicholas Copernicus, right? He lived from 1473 to 1543. So you're talking about astronomy is a very old science, right? And the Bible talks about it anyway.
But if I may interject here, Brother Milton, when we look at the dates, let us understand that the Catholic Church dominated all of society in terms of management.
Yes. So religion,
rulership,
science, government,
control,
business, education. They were the rulers. The church ruled the world. So everything comes under their purview.
Yes.
So any scientific thinking and thought was also
If it was
controlled.
not of the church.
Yes, was also controlled by the church, yes.
But if it was not of the church,
It was rejected. Yes. So this Catholic gentleman now furthered the theory by predicting elliptical, sorry, I jump a step. So Nicholas Copernicus, who is a Catholic cleric, but he's also an astronomer, right? First proposed a predictive mathematical model now known as heliocentrism. This was followed now by Johannes Kepler.
Johannes.
Yeah,
Come,
Kepler.
Let's learn the language here now.
Kepler is
This
a very bright guy. You know.
Austrian Polish name, Johannes Kepler.
Yeah, all right, sir, you know the words. Johannes Kepler, who lived 1571 to 1630, who furthered the theory by predicting elliptical orbits of the planets. Now, he struck it right, because that is what it has turned out to be. So Kepler, I guess, would have been considered one of the first persons. And of course, the essential telescopic observations of Galileo Galilei in 1560, who lived from 1564 to 1642. Solar studies have been rising leaps and bounds ever since. And last week, was it last week or the week before, we talked about the James Webb telescope. And they are very, what's the word? Ambitious where that telescope is concerned. Their intent, Mr. Sterling and my brother, is that they are going to be looking all the way back to the beginning of time with this telescope.
We are not being facetious, but I really wish they'd look on that one.
I want to know if they're talking about the Big Bang that they claim is what caused the beginning of the universe. Or are they talking about the creation of God? In other words, are they looking, is it the intent to look into God's business with this telescope? I also said earlier on, is space study and travel the next Tower of Babel, my brother?
Oh yes, it's out there now, and they are
James
tuning
Webb,
it up,
James Webb
balancing the mirrors to
Yes.
focus whatever image they are picking up, so that they can get a better idea of its magnitude, of its composition, of there are different functioning, what do you call now? There are different parts of the computer, of the whole telescope, electronic parts, units which may determine certain things and help to help the image to be sharp or give an X-ray vision of it, so you can see through certain aspects of it. Right? You have the X-ray mirrors,
X-ray,
you have the ultraviolet, infrared, so on and so forth.
So that so this one telescope can look at everything, because
Right.
not every body in space is visible as in the visible spectrum that we looked at earlier on. Now, the sun is what is known as as our scientific knowledge has increased, so too has our understanding that the earth is merely a piece in the larger structure we know as the solar system. What we have also discovered is that although other planets and bodies in the solar system may not possess life, the sun is just as influential to them. So the sun is not just looking out for the earth, all of the other planets. The sun is what is known as a main sequence star, that is a sphere composed primarily of the two gases, hydrogen and helium, such that certain conditions are met. In other words, this is really how, in terms the scientific definition of a star, hydrogen and helium. Because as scientists gather these information on space, they sort of organize them into the various ways how they are described, and so the term star carries with it a definition. So you don't just name anybody in space as a star. There are a certain category of information that is required to go with that. All right, Elder, let's look at some facts and figures about the sun.
Size of the sun. The size of the sun compared to the largest known stars, which are red giants, is not very big. However, if compared to the more or most common type of star in the universe called red dwarf, the sun is quite a bit large. Thus, the sun is not the biggest star in the universe, but it is definitely larger than most.
As far as the sun's mass compared to other bodies found in our solar system, the sun is easily the most massive. The sun alone contains 99.8% of the total mass in the solar system. So the sun really is giant over the planets and the comets and the asteroids and all of the other bodies that we spoke to earlier on constituting our solar system. Right,
Yes,
and that's where the
energy for
our
our life
brother is
here.
saying, the energy that drives the solar system comes from the sun, right? Now, in terms of size, Elder, the sun has a diameter of roughly 1.4 million kilometers, 870,000 miles. To put this in perspective, this is almost 110 times the diameter of the Earth. What this means is that about 1 million Earth could fit into the sun. So the sun is about 1 million times the size of the Earth.
My friend, there's a thing when it's not when the WhatsApp is not true.
Oh, fake news. All right.
Yes.
Pick up on 4, Elder.
The energy created by the sun's core is nuclear fusion.
Yes, and we talk about
This
that earlier.
huge amount of energy is produced when 4 hydrogen nuclei are combined into 1 helium nucleus.
Right, and so helium has an atomic mass of 2, hydrogen has an atomic mass of 1. So when you combine 4 hydrogen, then you're going to end up with 2 helium.
Okay.
Right?
The sun is almost a perfect sphere that is round.
Yeah.
Considering the sheer size of the sun, there is only a 10-kilometer difference in its polar and equatorial diameters. This makes it the closest thing to a perfect sphere observed in nature.
Wow, isn't that something? The closest body in nature that approaches a perfect sphere in its shape. Because most of the time, when you look at a perfect circle, it is something that mankind has created. So either we draw it or we machine something. But something naturally occurring in nature just doesn't generally have that perfect round. But the sun, they said, approach it the closest in nature. Now the sun is traveling at 220 kilometers per second. So anytime you get a plane up to 400 miles per hour, you say it's a travel, man. The sun is doing 220 kilometers per second. Anything you can think of. I can't run it down, but when we talk about space travel, there is something that the spacecraft can do it because they have to be able to do it to escape the Earth's atmosphere. Now it is around 24,000 to 26,000 light years from the galactic center, and it takes the sun approximately 225 to 250 million years to complete one orbit of the center of the Milky Way. So Elder, where are we
So
now?
in other words, what it is saying, we take 1 year to go around the sun,
While the sun
is also on its way around the galactic center. It is said that there's either, lately I've seen this one which says there's this shine that you see in the middle of the galaxy. It's either some large body there or it's a black hole.
Yeah.
Right? Black hole we can discuss another time, but that's a serious element in space. So, well, the sun is moving and it's carrying the planets with it. No. It is traveling at a speed where it is carrying the sun, the planets along with him.
So another
just
way,
as how the earth
yeah,
is carrying the moon along with it.
Yes. So another way of putting it then, my friend, is that the planets are moving at the same speed
Yes.
as the sun, because the sun is going around the galactic center and the planets are attached to it in the sense of it's pull. Yeah, continuous going at the same speed as the head, right? Now, in terms of size, the sun has a diameter of roughly 1.4 million kilometers, 870,000 miles. To put this in perspective, this is almost 110 times the diameter of the Earth. Oh, I read that already.
Yes.
What this means is that the Earth, the 1 million
The
Earth,
earth is very small.
yes, will fit into the sun.
Because considering our sun is not the biggest.
No. 1 million Earth will fit into the sun. No, it's not the, and it's not the largest
planet.
sun. It's not the largest star. But when you compare its size to the Earth that we know, 1 million, it is 1 million times bigger than the Earth. It takes 8 minutes for light to reach the Earth from the sun. The average distance from the sun to the Earth is about 150 million kilometers, or about 93 million miles, right? Now, light travels at 300,000 kilometers per second, so dividing one by the other gives you 500 seconds, which is 8 minutes and 20 seconds. So this is a good way, you know, of, you see, a good scientific way to actually measure distance in space.
So this is an improvement, I suppose, improvement in scientific instruments. That was the word I was trying to find, instruments.
Yeah. To actually measure these things.
Yes, because it has long been the theory that light travels at approximately 186,000 miles per second.
No, that is still correct, you know. This is a conversion. Remember, this is...
Well, yes, it says
this is
kilometers.
Metric. This is metric.
Right.
So, yeah, man, it's
So it's
that
roughly
has
about
not
the same.
changed.
It's the
God's
same.
speed of light has not changed.
Can't
You know?
change.
No, this energy can reach Earth in mere minutes, but it takes millions of years to travel from the sun's core to its surface. Now, here is where the debate comes in, and it talks about million years. We speak in terms of 6,000 years, Elder. But if the science is right, then 6,000 years is just a blip. And it would mean that the science, if we're going to work with the 6,000 year theory, then what we're seeing of the stars out there, they are much closer than the science is predicting.
Let's understand this. The way we measure distance varies from the relationship of one body to another in space. Because then you would say, then how is it that we have not seen the difference? Because all the stars, everything is moving. So how is it that when your parents were babies or children, they saw the Big Dipper, and they saw Orion, and they saw the different constellations, and you come up now an old man, and you are still seeing the same thing? Shouldn't there have been a difference? But the theory is that they are so far away that the time lapse for observing any noticeable movement in the shape is too much for our lifetime of measuring time.
Yes, and so that's why in
so
this
you won't
case,
see the difference in your lifetime, because it's going to take millions of years
yes, and that is
for
what
you
they are
to
saying.
see that change. True.
No, but even then,
But
But even then, though, brother, is that still in the past, you know, the human history is only 6,000 years. Now, if the light from the sun gonna take a couple million years to reach the center, then 6,000 years ago, they would still be seeing whatever we are seeing now. They would still be seeing it. Either that, or the science is wrong. Right? The science about time is wrong. Now, the distance between Earth and Sun changes. This is because the Earth travels on an elliptical orbit path around the Sun. The distance between the two ranges from 147 to 152 million kilometers. So this distance between them is 1 astronomical unit. That's how you measure this distance.
The distance between Earth and Sun is the astronomical unit, and they use that to measure
the other
distances between us and the moon, how much of an astronomical unit it is, how much between here and Mars or here and Jupiter and so forth.
That's right. Very good. Now the sun rotates. Now this is an interesting fact. The sun rotates in the opposite direction to Earth, with the sun rotating from west to east instead of from east to west, like the Earth. So they are countering each other in their rotation. So this is the Earth rotating on its own axis compared to us rotating on our axis, opposite. And
it couldn't work the other way unless you would see sunrise and sunset.
Yeah, and we would also probably gone off into space. They would probably gone off into space. So God has balanced it. You understand the science and everything that we make. Because the use of magnetism, I spoke earlier on about generator that generate electricity. It's with the use of magnetism, and magnetism is what gravity works off. That's the principle of gravity. We're merely borrowing this science for our use on the Earth. Now the sun rotates more quickly at its equator than it does close to its pole. This is known as differential rotation. So many facts and figures.
And why do you think that the rotational points are different?
To maintain the balance, if I want to put it simply.
It is not a solid body. It's a gaseous.
You're talking about the sun.
Right. It's a gaseous body.
So there's a little stretching.
Hence there's the stretching and pulling and so.
Yeah.
So you're going to find that the larger portion may take a certain amount of time, while the smaller portion spins at a different rate.
All right. Now the sun has a powerful magnetic field. When magnetic energy is released by the sun during magnetic storms, solar flares occur, which we see on Earth as sunspots. Sunspots are dark areas on the sun's surface caused by magnetic variations. The reason they appear dark is due to their temperature being much lower than surrounding areas. And earlier on we talked about the color of the stars tell you how hot they are. So the sun being a red star.
No, ours is not a red star.
More like an orange.
Yellow.
Yeah, yellow.
We have yellow
so
sun.
Temperature is a little higher than a red star. So when you see a dark spot, that shows you that that area, the temperature has dropped a bit. And there is a phenomenon they call solar storm. And the other day, I can't remember how many years back when we were preparing for one. And one of the impacts that we realize is that it will
shut down the grid.
Yes, attack the electrical
grid.
It
will blast it away.
Right. So, and these things are real, friends. You know, this is. But the good thing about it is that these things, you could say, heal themselves, and that goes back to the point we made earlier on when we said that God has designed nature, the universe in our way for it to balance itself.
Generate itself.
And I want to make a quick point here. We often speak that nature is disruptive. We talk about hurricanes, we talk about storms, we talk about tornadoes, we talk about tsunamis, and all of these upheavals in nature. But have you ever noticed that these, they don't go on indefinitely? They happen, and then they come to us. If a storm is coming, your only burden is to weather the storm.
Mm-hmm.
Because it will not last indefinitely, Sister Sterling. Why? Because nature will just rock and balance itself to eliminate the storm. In fact, it is theorized that storms and earthquakes, well, certainly for earthquakes, all of these upheavals in nature is nature's way of creating a balance, something that is going out of balance. So storms, for instance, are actually one method whereby the atmospheric imbalance around the earth going off, and it creates a storm, and the passage of the storm recreates the balance. When you talk about the ocean currents, the earthquake is merely a pressure buildup in the earth being relieved, right? It is like on your pressure cooker when the lid, when the temperature, when the pressure in your pressure cooker gets too high, the lid lifts, blow off the extra steam, and the pressure come back down to normal, and the pot is merrily going on its way again, right? And in the power industries, for instance, with the boilers that they use, they have these pressure relief valves, and the purpose for these is to relieve any extra buildup of pressure that may occur normally or abnormally, so that the boiler don't destroy itself. So in the same way, nature will be in upheaval in order to balance out the forces that are already built in nature. And that's a natural feature to ensure that the earth continue in a balance. Same thing with our lives. We relieve pressure to, Mr. Sterling. He said, when
things get too ahead,
yes, when you're angry,
everybody start to run from Mama, because Mama depend the war path.
And in fact,
when Mama cool down, now everybody coming back and we back to one.
And in fact, too, it is said that one of the reasons why we suffer ill health is that we're not following the principle of nature, of letting off the pressure. They say that we men absorb pressure. And we don't show our feelings, and that's why we die early. The women, on the other hand, they are not ashamed of giving you a piece of their tongue. And that's their way of relieving the pressure, and they live longer than us. Is that a lesson to us, men? Yes, my brother. Yes, because the earth has to remain in balance. God created it in a way to remain in balance, to be in balance. And if it takes a storm to recreate a balance in the atmosphere, then the storm going to blow. You are a part of nature. God give you the wisdom to live with and to escape from the impact of the storm. That's why we are given the wisdom. Now notice the birds. When you see birds flying, yes, the older folks who don't have the scientific, what have you, will say, yes, rain. Now for me, friends, what I use for rain, and I can tell you 99.9% of the time, it is correct. When I see those little red ants, and when you see them hurrying and hunting food, rain is coming, and it never fails. I have to laugh sometimes. I said, boy, God is so
Go to the ant, thou sluggard,
yes,
and learn.
Yes, and the movement of the birds and the movement of the animals tell you when something is changing in nature. In fact, when there's a tsunami that has occurred far away, the animals pick it up long before human beings. The great tsunami that destroyed South America in 2014, it was, Boxing Day. They said that the animals, yes, the animals, the Indonesia and all of that area, the animals, people just said the animals took off for the hills. And there was this account of an elephant that was on a chain, and the elephant burst the chain. And a tourist was on the elephant. And the elephant ran to the hills. And by the time the elephant reached the hills, the water was at its foot.
Oh, mercy.
Now remember, it headed for the hills, and a tsunami is like 50,000 feet in the air.
50 feet.
Yeah, 50 feet, right. 50 feet. So all the dogs, everything just head for the hills. The animals that were caged, they were beating themselves against the cage and trying to escape. And as the tsunami wave draw near, they just get quiet because they now know that it's the end for them. So they just settle down to face their end. But nature is in balance, and nature will act to maintain its balance. So we said all of that, friends, to say that it appears that in the universe at large, the same system is at work, where the universe seems to be replenishing itself. That is the evidence that is coming out of, the observation of the universe that mankind is now able to do because of the advance in technology. Now there is a debate going about the time in which we're talking, because astronomers speak in millions and billions of years, while we from our creation account will speak to 6,000 years. But we also said that possibly there is a synergy between the two ideas, except that how God designed it 6,000 years ago, millions of years would constitute how the universe would propagate, if you follow what I'm saying.
But
in other words, 6,000 years, it would have been made 6,000 years, but how it is operating is that it will go on indefinitely, right? It's created to go on indefinitely. So what we're observing is a little piece in time, but we're seeing where in that this is how time would move. My theory, of course, right?
Well, but what I'm saying, it could be debatable.
It is. It is a strong
because
debate.
Before the flood, there was no upheaval of the earth. But after the flood, where the Lord allowed the land to break up and the fountains of the deep exploded up with water.
Yes.
And you find mountains now coming up after that and all of these things. Could it be that nature became in upheaval on the earth, thus creating these conditions of earthquakes and tsunamis and so forth? Because this earth is still recovering from the flood.
Right.
But if we should state that this is what is general true nature in the universe, we are saying that God is not in control.
All right.
Because things will just go up and down and, as you like it.
Yes, and God did speak to Christ controlling the storms and all of that. But the fact that Christ was controlling the storms tells you that storm was the way nature was behaving, certainly in Jesus' time, right? Now, the point you made that this came after the fall is quite a relevant one. In other words, one could say that the earth was not created initially to have to be balancing itself, but that God would have placed in it that ability to balance itself, so that it while it is living through the imperfection caused by the fall, because the Bible does say that nature was affected by the fall, right? So yes, that is a very good point, that even though we're relating from a scientific standpoint and what we observe that nature is doing, you cannot stray far from the biblical control mechanism over the knowledge that we do have. Elder, I think we have used up a lot of time, so we're going to run along. Let me just quickly read some of these facts and figures. The sun generates solar winds. These are ejections of plasma, extremely hot charged particles that originate in the layer of the sun known as the corona. And they can travel through the solar system at up to 450 kilometers per second. The hottest known star is the R136A1. It's a massive and luminous star. It is the most massive, and the term here, massive, don't necessarily mean size. It means the amount of matter that is in making it up. So like a solid body is said to be more massive than a body that is just a gaseous. Even though that solid body is smaller. So I just want you to understand what the term massive here means. It is also one of the hottest stars, and it is located in the large Magellanic Cloud. Now the Magellanic Cloud is a small, galaxy.
Nebula.
Yeah, it's a small galaxy that rotates.
Galaxy, not a galaxy. It's a nebula.
Well,
a cloudy.
yes. It behaves like
section.
a galaxy.
No man.
and it's
Get
close
it right.
to the Milky Way. It's not a direct part of the Milky Way, but it's close.
A galaxy is like a handful of sand. And each sand grain is a star.
And then each
So you
star
have different handfuls of sand. These are different galaxies in space, right? But you have a bunched up amount of stars clumped together. So the Milky Way is one, and within that, all the stars you see, well, according to Edwin Hubble, not all that we see is part of our galaxy. There are some very faint things which are outside of it, right? Which may be galaxies, but they are so far you can only see that little pin of light, right? But the stars that you see in the night are all part of our galaxy. That's why we can see them.
Our small little teeny weeny part that we can see. All right, running along. The image shows the central region of the Tarantula Nebula in the large Magellanic Cloud. Right? The young and dense star cluster R136 can be seen at the lower right of the image. This cluster contains hundreds of young blue stars, among them the most massive star detected in the universe so far. So what this is saying is that the most massive star that they have identified in the universe so far is actually close to our solar system, close to our galaxy. Now, using the NASA ESA Hubble Space Telescope, astronomers were able to study the central and most dense region of this cluster in detail. Here they found 9 stars with more than 100 solar masses, right? Now look at some key facts and figures. R136A1 is approximately 163,000 light years away from the Earth, and is estimated to have be around 315 times the mass of the Sun. So this star is 315 times bigger than our Sun.
Hence, our Sun would need 315 times what? 100 or a million?
Million.
To be
for the Earth
equal
to fit in it.
Oh my gosh.
Because 1 million,
Oh my gosh.
1 million Earth fit in our Sun. While this one
so
is
it's 315 times 1 million. That would be
315 million times the size of the Earth. R136A1 is up almost 9 million times more luminous than the Sun, meaning that it is 9 million times brighter than the Sun. R136A1.
So you could say then that the distance Saturn is, or not even Saturn, but beyond Pluto, that body would have to be beyond Pluto in terms of that distance to be within a habitable zone of that star.
Right.
Wow.
Now, R136A1's temperature is estimated to be around 53,000 to 53,000 K, which is 53,000 Celsius, or 95,000 degrees Fahrenheit, or about 10 times hotter than the Sun. So, Elder, so you're saying that you have all these plasma and these ozone layer and all of this protecting the Sun from the little
planet from the Sun.
From the little temperature coming from the Sun. I have to say the little temperature now, because this star is 10 times hotter than the Sun. And it has a diameter of about 30 million miles, or 48 million kilometers, about 35 times bigger than our Sun. 90, wait, go back a little bit. It tells you.
Let's rephrase that question.
It is.
How far is our Earth from our Sun?
No, he wants to know how far that star is from the Sun. R136A1 is approximately 163,000 light years away from Earth. And it is estimated to be around 315 times the mass of the sun. So just minus 93, when you convert 93 million miles to light years, it takes
0.01.
Right, so that would give you, so we would have to work it out from what we have here, because that figure is not given. We'd have to infer from the maths.
My brother, it's an eternal distance. Because if light travels at 186,000 miles per second, so by the time I say, who that to you? That's about 2 seconds. So that's what? 2 times 186.
That's
18.6. 36. So 340,000 miles in 2 seconds probably. So if you, how many seconds are there in 1 year? You understand?
All right.
So 163,000 light years is the amount of years it's going to take for that light to reach us.
Yes.
From that body.
And I'm going to do the maths. I'm going to do the maths.
It's too much.
No, let's run along, Elder. R136A1 radiates more energy in 5 seconds, get this, in 5 seconds than our sun in an entire Earth year. So in 5 seconds, the energy coming from this star is what it takes the sun to produce in one of our year, right? Though it is the most massive and luminous star ever discovered, this does not mean it is the biggest in size. You can fit well over 4 billion suns into R130A1. So it is 4 billion times the size of our sun, right? Now, R136A1 produces about 50 times more, 4 billion. 4 billion of our suns. 4 billion of our suns can fit into that sun. If you should try fit our sun into the circle of that, it's 4 billion times.
In other words, try to fill up a football with marbles.
Yes, right, that way, the volume. All right, now, R136A1 produces about 58 times more ultraviolet light than normal light, and that's why you see that color that you see there. Now, R136A1 dimensions are far smaller than the largest stars, red supergiants. That means as big as it is, there still are bigger ones. But this is the biggest one that we have discovered. They are several hundred times bigger than R136A1, but not as massive. In other words, what this is saying is that they are bigger in size, but they are not as dense as 136A1. Despite the large mass and modest dimensions, R136A1 has an average density of around 1% of the sun's. So the sun, though it is much smaller, is much denser. It is like Jupiter. Jupiter is such a large planet, but it's really a gas. So the Earth, so much smaller, is much more massive because the Earth is so much more dense, right? The whole of our solar system. All right, now, so the density at about 4 kilograms per meter cube, it is over 10 times denser than Earth's atmosphere at sea level. In other words, it's gaseous, in terms of its gaseous description, in terms of its density, comparing it to the atmosphere, because the atmosphere of the Earth is gaseous. It is 14 times denser than the atmosphere. If R138A1 were placed, listen to this, my brother. If R136A1 was placed in the solar system where our sun is, right? So you replace our sun with this star. Earth will probably get destroyed in under 1 day. So that shield that you talk about would probably just keep us just for 1 day. And then we're fried. The remaining planets will get destroyed, most likely in about a week. So you see why God placed the earth where he placed it? To shield us. Because he created the star, but he created the earth too. And he placed us at beside a star, under the control of a star,
At a distance where we'll
at
be
a distance from
comfortable,
the star, that we
where
will
things
survive.
can grow.
No, I see Elder Finsdale said that sin results, no, he first said that the earth recalibrating and having a reset reflects design. Of course, Elder Finsdale. Therefore, there is a designer. God is good. Then he continues, sin results in the upheavals of nature. God designed his creation to renew itself, but not in the drastic and disastrous way it happened. So what he's saying is that the replenishing mechanism was built in, but the destructive way in which it is done now is as a result of the impact of sin. And he said each discovery, each revelation tells us of the awesomeness of God. Mykola said, scientists will never truly understand and explain everything. God's ways are always higher than ours. That's so true. Mykola and Novlet said, it is a pleasure to share in the word of God with you. We serve an all-powerful God. Indeed. And friends, I must tell you that not only am I learning a lot about, nature from this study, but how large God's property, friends, the amount of property that God's own. I really didn't know that God owns so much property, and that I am just a little...
Well, we know he owns it, but the expanse and the extent of it is hard, is mind-blowing.
Yes. Now we're running along because we want to finish this this week. We know we have taken up more time than we normally would, but we really want to get to a different topic next week. So bear with us, friends. Origin of the word star, Old English theora, star, from Proto-Germanic sternan. Source also of Old Saxon stero, Old Frisian stera, Dutch ster, Old High German stero, German stern, Old Norse, you are the one who called these words. Sterna. Swedish sterna, Danish sterne, Gothic sterno. This form, pi, root, stare, star. So those are the origins of the term. So star then did not come from the Bible. This is a word that we borrow and use in writing the English version of the Bible. This was interesting, Elder. Astrological sense of influence of planets and zodiac on human affairs is recorded from the mid-13th century. Hence, person's fate as figured in the stars, right? In the 16th century, star-crossed means that you're ill-fated. From Romeo and Juliet, 1592, meaning lead performer is from 1824. Star turn is from 1898. Stars are the ranking of the quality for hotels, and if you're not staying at a five-star hotel, you're not staying anywhere, right? And originally in Baedeker guides, that's where it came from. Now, sticker stars as rewards for good students are recorded from 1977. And hear this now, brass star as a police badge is recorded from 1859 in New York City. So New York City police badge, the police badge, that is a star. But
even the Old West, they use a star.
Yes, I'm not wondering. The sheriffs in the Old Wild West use a star for their badge. Star cluster from the 1870s, and to see stars when one is hit on hard on the head. It's a gee what? I bounce my head and I see stars. And so these are some of the interesting use of the... All right, we have exceeded our time. We can't go into the planets today, and I think we enjoyed our study on just looking at the sun and all of the comparison of the sun with its brothers and sister stars, and how massive God's property is, and how massive the space in which they exist with respect to each other.
And he controls it all.
Yes, and I am humbled, my friend. I am truly humbled by the knowledge, and I am appalled in like manner that we create so much problems on the earth.
I tell you.
And we live on such a small piece of the universe. Why we don't take care of it? Why we're destroying it? We're going to show you that the rest of the universe is, as far as we know, is uninhabitable. So why are we destroying the habitable one? That is something to ponder. Next week we're going to pick up on the planets, and we're going to look at our neighbors who are with us in this solar system, who share with us their nature, the difference between us and them in our makeup and our relationship to the sun. Elder Finzel, the sun, you know, that powerful star that mankind originally started out to worship, only for us to know today that certainly God did not create a star that is to be worshipped. We know that, but that is what they used to do in the past. Science has helped. That's why we can't flog or beat science. Science has helped to dispel these practices. You understand? That the sun is not a god, no matter how good and how powerful it is. And the purpose that the sun serves. We're looking at the purpose of creation, and God created the universe, not just the earth. Let me thank our technical team, Kimberly Mason, Keroy Campbell, Jordan Sterling, Shamar Page, and I'm sure I see Sheldon Sterling somewhere around. Of course, Sister Sterling for refreshing us, and of course my brother. Remind us if your name, my brother.
Renford.
For joining us.
Our resident questioner today.
Yes. Thank you for joining us. Thanks, Tech Communication Team. And we're going to go out in prayer. Join us next week. Heavenly Father, thank you for the knowledge that you have revealed to us of your planet, the Earth, our neighboring planets in the solar system, the galaxies, the universe. You are such a powerful God, but such a loving God. And we thank you. We pray in Jesus' name. Amen. See you next week when we look at the planets.
Like a thief in the night, Jesus is coming again. He's coming with power and glory to reign. Coming with all the heavenly hosts. What a glorious time that will be.